start recording for posterity's sake. Yeah, I guess just keep me updated on the amount of people that are in the thing, since I won't be looking at it. But yeah, we'll give it a couple more minutes before I start. Yeah. Yeah. Seems like most people are taking the online option. Doesn't really matter waiting on it. All right. Yeah. So I guess I'll just go ahead and get started then. So yeah, thank you to everybody who has come. Can everybody hear me okay? I'm using my Mac's speaker, so I just want to or microphone, so I just want to make sure you can hear me. If anybody in the virtual stage could let me know. Yeah, everything's audio sound okay? Can you hear me? Yeah? Yeah, I could always change it, but yeah, so assuming everything's fine on that end, then I'm gonna go ahead and start. So today I'll just be going over basically what microservices are, how they're important to like real industry programming, how I've kind of used them, and I'll be showing that off through like using Google's remote procedure call and Protobuf libraries. So I don't know if anybody's ever heard of microservices. It's kind of a weird term, but it's definitely more relevant today because of cloud computing. And if you've ever heard like the term distributed computing, that's something that microservices is intimately a part of. So a microservice is essentially like a different way to think about composing your software, your program that you're writing. So as opposed to a monolithic architecture where you write a piece of software and every aspect of that software is contained within the binary executable, a microservice is loosely coupled and independent of like one specific solution or implementation, and because it's a small piece of code, a small service, it can easily be reused and scaled, tested, maintained by a small amount of people rather than having to have a lot of people working on one large code base, one large monolithic software. You have a series of different microservices that communicate with each other and sometimes share resources. Hi. Welcome. You can sit wherever you'd like. I just got started talking about microservices, so you didn't miss much. Okay, so yeah, in a lot of ways, microservices are similar just to like fundamental ideas of abstraction that we learn in computer science. It is as we'll get into the name, a remote procedure call. It is executed remotely. It is really like a procedure in the sense that some snippet or some section of code is going to get run, but it is not in like the local address space. It's somewhere else. So gRPC is a remote procedure call framework designed by Google, and it's based actually on internal frameworks that they use at Google, one of which is called Stubby, or like one of the descendants of it is called Stubby. And that's essentially how a lot of Google's internal services are ran and operated. They are themselves a remote procedure call that accesses, database information and other things related to that service, but the actual procedure and the actual execution of any particular Google service, like a Google Maps search, is fundamentally happening as like a remote procedure call. And these remote procedure calls make use of the protocol buffer format for exchanging data and serializing it. So we'll get into the comparisons a bit here soon, but similar to how in an HTTP response request you may send or receive JSON as your data exchange format, protocol buffer is its own exchange format, and it has its own built-in technologies and compilers, so things that help not only generate code for you so that you can worry less about like underlying abstraction details, but also creates just a more like efficient alternative versus JSON, which might be can get very large and verbose and difficult or strenuous on like a exchange to send back and forth. And then there's a lot of more advanced stuff in gRPC, like load balancing, tracing, health checking, and authentication. And this is, more important for people who are interested in that kind of deeper server development type of stuff. So as I was getting into a bit before, it is kind of like an alternative in a sense to REST and JSON. You can set up gRPC in a similar kind of client-server architecture that you see with a lot of common, chat bot or chat server applications. If you're learning how to do like basic network programming, like in CS342, it's a similar kind of setup, but gRPC, making use of remote procedure calls, has advantages, not only because of the format itself being like scalable and faster, but also because you can implement it into your remote procedure calls. So actually, and this was a big thing that I was surprised about when I like got my internship at Google and first like worked professionally, is that remote procedure calls, RPCs, are like kind of everywhere. A lot of companies in this post-cloud kind of world where cloud computing is cheap and inexpensive, a lot of companies run their main software services as microservices, or certain aspects of their software is encapsulated in a microservice. And it's enabled like very quickly scalable development, kind of like I alluded to earlier. And it's good to know about remote procedure calls, how they work, how like just kind of understanding the networking behind them, because it's very likely that if you're working as like a software engineer, back end, or even full stack at any one of these companies or more, you'll likely encounter remote procedure calls, setting them up, monitoring them. There's going to be a lot of different things you have to consider about how your application, once it's running indefinitely, like having good tools to monitor and maintain that is important, and gRPC provides that. So another good thing about gRPC is opposed to some other, like not only HTTP server solutions, which sometimes the ease of implementation is dependent really on the language you choose. So like building a server client application in C++ versus Java are completely different levels of complexity. But gRPC and protocol buffers as well, they're multi-language, so you can write. There are wrappers or ways to use these libraries in multiple languages. So, if you're more accustomed to Python, it's very easy to quickly get something set up. Or if you want to get like more advanced or more sophisticated with your design, you can go with the C++, and you have just as much access to the library. So I'll get into a bit more of the protocol buffers because I find these to be like really useful, even beyond just like building a remote procedure call, but just how much more convenient this method of storing your data can be. So like I said before, it's language and platform neutral. You can use it with all those different programming languages I said before. And I kind of mentioned it a bit earlier, but I glossed over it. So when you let me pull down a bit. So yeah, when you defined a protocol buffer, it looks a bit something like this. So in a similar way that a JSON file can have different like hierarchy structures in it and different components, the protocol buffer format allows you to define different types of variables like strings, integers. You can even define like a repeated variable, which is itself kind of like a linked list, like a pointer-based linked list. So there's a lot of options with the protocol buffer language. And once you have like your idea of your service or the variables that your service will be exchanging, the protocol buffer, it has a compiler basically. So what you do is you'll run the compiler on this person.proto, and let's say you're working in Python, it will generate a full Python file for you with classes and member functions based on what you've written here. So you'll have, message person will become itself like a class object of type person with its own member variables, name, ID, email, in the same kind of structure as how you defined it in the protocol buffer. And then you can import that into your gRPC project or really any type of software solution that you're using and easily access all the data from it. So instead of having to manually check strings from a JSON response object, now you can programmatically encode access the name or access the ID and access the email. And this like simple aspect to it makes dealing with and just exchanging data a lot easier for you as the programmer. Like just intuitively, everything is now a member of your class, and you don't have to write out that full class yourself. It's generated for you based on the simple description language. So yeah, this is like just a little diagram basically kind of showing how you can have multiple different types of clients that they're around. So let's say your server itself is C++, you've got some underlying libraries that they need to be in C++, you need more finer level of control, and you design your server in C++, but you want to ship this product or this this idea that you have out sooner. So you're building your clients that your users will interact with in Android or Java or Ruby, and they can have their own sophisticated front ends without having to rely on the same technology that you chose for your server, and they communicate in the same language, which is the protocol buffers. And this is a term that you'll hear often in like distributed computing or with not gRPC, but just remote procedure calls in general, is a stub. And that's basically just kind of like a piece of code that runs somewhere else. It's not running in the same place where this server is at. This is somewhere else in the cloud, and your code stub is going to run send a request, get a response. It's very similar to a lot of the, fundamental design architectures that are out there, like that method of exchange. But because they're separate and they're communicating across the internet, it just allows it to scale a lot better than if they were all written in the same technology and you had to, update individually for your client and your server. So I included some links, just not only about like gRPC and how to get into it, but also microservices as like an overall concept. And then for GDSC, UIC, we have, like, I started a repository just called Microservices where I'm implementing.
Do you want me to make that public? It's private.
Is it public? Is it private? Yeah, go ahead and make that public then. Yeah, so we'll have this repository opened up, and it has basically like the most basic client and server kind of hello world exchange example that you can try and basically run yourself using Python. And then over time I will add to that repository and kind of expand on the service based on more things, more events that we do throughout the semester. So because you can add just a lot of different functionality into a small microservice. So that's kind of my goal with that repository once we make it public. And then something I just thought was kind of funny, like once I had the internship and I realized, like, oh my gosh, like dang near everything is running on some sort of remote procedure call. It was just, I started noticing them more, noticing the word remote procedure call more just in the wild, and seeing other programmers talk about it, just how, because it just like anything, microservices, they allow for like really scalable, deployable development, but also they can be really easily misused. You can make a microservice that does more than it needs to, like the goal of it should really be one specific purpose, one specific function. In the same way that you try to abstract like a good function with good parameters, a microservice is the same concept. It should really only serve one purpose. And so, it's definitely like there is some philosophy and idea that goes into designing a good microservice. Not everything needs to be a microservice. Some things work better if they are happening locally on that whatever program, or if you have a server, maybe not every single method of exchange is a microservice. You could have things that are happening on the same like local network, and those things will ultimately just be the same program. They don't need to be abstracted away. But I did think it was funny to see Elon Musk when he bought Twitter, and him going through and seeing tons of remote procedure calls that the Twitter engineers had put together, and at least according to him, having a ton of remote procedure calls running all at once was causing slowdown. So that's another way you can kind of see it as like, oh, if you try to ship too many microservices, if you try to over-engineer, that can also be kind of that can hurt you as well. But that's like the extreme end, I feel like, is the Twitter engineers and their 1,200 remote procedure calls. So yeah, I didn't want to go like too deep into the technicals of gRPC, but I figured I would at least show off. Like I said, we will have that repository open with these basic client server examples. You'll be able to like run and test that out. It really is just like your basic hello world. But something I personally have done with like protocol buffers in my own time was like using them basically as like a wrapper over like a primitive API. So like this TD Ameritrade API, it gets responses in JSON from TD Ameritrade. And essentially what I did, instead of having to, receive the JSON object and then, like I said, manually access these different fields by like a string or, storing them in a hash map, I basically just took the time to put together, these different protocol buffer definitions, and I got a couple different remote procedure calls, and essentially how I have it built is these RPCs are making the communication with that TD Ameritrade like stock API for me. So it, I have all the information for my account request. Let's see, where's the account request? Yeah, so the account request is just like, oh, I want my account ID. So this will, in the code, it'll pass that along to my, like this is like an example kind of, let's go down here. And this in general is kind of how, when I was working my internship at Google, a lot of my code looked something similar to this, where I had my service that I defined, I had my protocol buffers that I generated myself, and we import like Google's Protobuf libraries, the gRPC libraries, and let's move past. So like this, for example, this send request is being used by, all right, here. So get account uses this TD Ameritrade service implementation. So what that basically is when I designed this this protocol buffer service, and it generated that code for me, it generated C++ code for me, which I believe it should be like somewhere in, maybe not in here, but service TD Ameritrade. Yeah, okay. So yeah, it actually generates this code. It's tons of C++ code that Protobuf generates for you, and this allows me to use let's go back to the service. Use a TD Ameritrade service IMPL, object, essentially, kind of in this same vein. So, and basically how I have it wrapped is I make the request to my API. Once I have it, I actually just use this library where I turn that JSON string into my protocol buffer method. So it'll basically, if the JSON response has, an account ID, it'll fill in that string. If it's got a description, it'll fill in that, and it just does all that automatically. And then I have the object that I want to interact with based on that. And so yeah, these are all kind of defining my different remote procedure calls. But this is a very small kind of localized example. When you are actually building when you're building microservices for like a company, you typically, everything's going to be more like separated. Each microservice, like I said, is going to be its own set of code, probably have its own like class and configurations for it, like whether or not it's live at that moment or you're just testing it. So there's more to it than just the Protobuf and like the gRPC code. There is also the maintenance and the monitoring of your server once it's live, and that's other stuff that kind of you can find inside of the gRPC library. So that's something you can look into more if you're like curious about that. And yeah, there's definitely like more advanced things that the gRPC library can do, like I alluded to earlier with like load balancing, more advanced server configuration type stuff. And the gRPC GitHub has a lot of really good examples, and that's where I looked and learned about using gRPC myself. Like after my internship, I was really interested in remote procedure calls, so I've spent a bit of time with this stuff. And yeah, so that's kind of the sum of the stuff that I have to say about microservices. Is anybody in here or on the chat have questions? Sure, go ahead.
Yeah, I have a question. So as you mentioned on the slide, that just like gRPC have like support like multiple languages like Python, Go, C++, and Java. Like, so just like there's some characteristic of like Go language, like they can do a concurrency programming in Go. So but just like some other languages like Python, they cannot achieve that. So how does gRPC of Google can fix that problem?
Like, do you just mean in terms of like like inconsistencies between like a client and server because they're on different technologies. So I think usually it really just depends on like what the service is specifically. Definitely there are gonna be, if it was trying to think of an example. Even going back to like the Twitter thing, if you have, your clients programmed in, some interpreted language, for example, and you're experiencing slowdown on them downloading, I think you could, as I was kind of alluding to earlier, you could do like a form of load balancing and serve those clients just based on basically what their capacity is to get resources from you. That definitely gets a bit more into like the more advanced configuration, but you definitely can, like, based off of the characteristics of the other gRPC clients, like even what platform they're running, you can direct how much resources you want to put towards them. I don't know if that'll necessarily help with like concurrency features, but like I said, if it's like a slower interpreted language, you can likely, push more. I mean, you're not going to be able to change how fast that program is running, but just make the experience smoother for that end user by prioritizing them. Probably best, yeah.
Could you talk about the GitHub repo that you actually, like the GDSC one?
Yeah, sure. So this was basically just I based this off of the like quick start for gRPC. If you don't already have like a Python and pip setup, I put that command there, and then you can use that to install gRPC and the gRPC tools, which I believe this includes like the protocol buffer library and protocol buffer compiler. So that's one thing that people may run into when they are experimenting with these technologies, is that protocol buffers is maintained separately from gRPC, but gRPC includes a shipment of protocol buffers with it. And when you're generating like code, because what I included here was a hello world protocol buffer, and commented right here is the command you would run. So Python gRPC tools.protoc. This right here means like protocol buffer compiler. Proto compiler is basically how I read it. So it's essentially taking this hello world proto. You would run this code like in your terminal. One second. Once you have everything installed from those commands, you would run this in your terminal, and it generates these files. So like if these didn't exist before, run that, and it generates those files for me. This is my protocol buffer output for gRPC. And it's not worth really reading these because you have your hello world proto definition. This is everything you should need in terms of how do I interact with my my service. So the basic, once you have this code generated, you can import it. So the micro client and micro server files respectively both import hello world pb2, hello world pb2 gRPC. And then, like I said, this is based off of the examples provided on the gRPC documentation, but it really is just a like you spin up the server, it listens, and when you have a client that connects to it, it will output hello to that person. I just don't think I had it running properly on like the school's network because they block like the port forwarding stuff. But you could try this at home, and they should communicate between each other, like running the micro server and the micro client. And you, like I said, this is based off of these quick start application or documentation here, and what they eventually get into is like streaming replies. So not just like exchanging back and forth, waiting for a request, waiting for a response, but you can also open like an asynchronous stream where the client and the server are continuously exchanging messages, and this can be advantageous in a lot of ways. Like I was considering building like a streaming service for like live stock prices, for example. You could just keep continuously like asking the server to pull more prices for you and keep updating something on your client's end, or like a chat bot if you want like multiple people connected to, or not a chat bot but just a chat room. You want multiple people connected to one server socket, you can do that with gRPC in the same way that you can do it with like your manual socket programming. So yeah, that's basically. I would like to expand on this, but I just started with like the basic micro service and micro client hello world exchange. Yes?
So how is gRPC related to like Docker and Kubernetes? Is it something like totally different? Or
It definitely is. So you would, like, let's say you have your idea for your server and your client, whatever your application is. You can very quickly use something like Docker as what holds that server, what holds your client. You wouldn't really need to spin one up for a client, but let's say for the server specifically, you can very quickly not only like deploy like the Linux operating system, and then put your microservice already on it and running as like an auto job, or however, I forget how it's set in Linux, but just so that it automatically runs. And that's how people like deploy and scale microservices quickly, is they use some sort of prefab kind of like Linux OS with Docker, or like Google internally, they had their own setup for how that microservice would get deployed, its own tons of configurations that went into that. But for someone just doing like a startup business, you could use Docker, put your microservice on that, and then it's just running, and you can whatever IP address that server you've created in Docker is now associated with, that's where all your clients would be sending their requests to. So yeah, let's see what else. Is there anything in the Discord that I should be aware of?
Someone couldn't see the screen, but I think that I can.
Oh, okay.
Yeah, if you have any questions on Discord, feel free to.
Let's see what it has on Go. Oh yeah, it's also like a Hello World server. See, I don't really use Go, but it does have options, tutorials, API guides for all your main languages. I've mainly only used C++ for gRPC and Stubby. This is another good example of kind of what I was looking at here earlier. Different types of remote procedure calls you can run, like just a simple request response format, server to client streaming. So this will take a request and return a stream.
But we have a question.
What's that?
Yes, so I just take a look on the project, and I see that every single time we run the compilers, there are two files that pop up, is .python and one is .python-i. So Python-i is an interpreter or something?
Yeah, so I think this is specifically, I believe this helps with associating like the naming convention as an import. That's how I think that's what that's for. But it's like I said, it's not the outputs of the protocol buffer compiler. Usually you don't have to worry about them. The only time you would really want to worry about it is if the compiler's version was different from your gRPC version. So like you can't use an older protocol buffer compiler output for the newest version of gRPC. Because like for that .pyi, like the integration there, may not be present in like an older version, and now newer versions will expect it. So that's really the only thing I would think about there, but you don't have to worry too much about like the contents of the files.
And also one thing is because I usually use the communication between the server and the front end.
Mm-hmm.
I usually use some REST framework like Fast API
Yep.
or Django.
Mhm.
So they usually have a documentation built up like to show what the schema for the API calls. So the gRPC also have that kind of documentation page.
If I'm understanding correctly, so like gRPC over HTTP2, yeah. Yeah, so yeah, there's this pretty detailed documentation on it, and I believe, so like I said, the exchange format is very similar to HTTP, but it has like an additional data frame added into it, similar to HTTP2, the protocol or the gRPC exchange. But can you explain what you meant again about the REST API?
So for instance, I develop a server just like getting the user account,
Mm-hmm.
and if I use Fast API, I just write the code for just like the schema, like user ID and stuff like that, if I go to localhost 8000 and then API documentation,
Mm-hmm.
then they will show me like the schema of that.
Oh, I see what you're saying. No.
The protofiles kind of do that.
Yeah.
You define, that's kind of.
Yeah. So there isn't anything built in. Like once you've launched your server, there isn't like that type of thing available for you to find. But the protocol buffers are essentially like the analogous thing, and their output is like the data. Yeah.
But sometimes just like it will show all the implementation for the server, like the API calls, and probably like if I have a client, I don't want to like for them to see those.
Oh no. Yeah, no. That type of information isn't going to be revealed to any of the clients. No. And there's nothing like once the remote procedure call is running, it's not going to reveal like any kind of internal information about the protocol buffer or its format or anything. No, all of that stuff is like secured in the exchange format, and then the only person who would have access to what remote procedure calls can we run in the server would be the person who has the proto buffer file, or you only allow your client to make requests to these specific requests. So like let's say you built a server and it's like some sort of like it has some admin RPCs, right? Like certain things that only you want to be able to request. No user would be able to see like a list of what remote procedure calls are available, and as long as you programmed your client correctly, they wouldn't be able to make requests to those calls on like you would have to give them permission to. So yeah, there's a lot of like security stuff built into it. You're not going to be able to see that type of information like just floating in the ether, which can happen with like HTTP if it's not properly secured. Hopefully that answered it, kind of.
Yeah.
But yeah, there's plenty of documentation to get more into like the security and like the configurations behind your RPC server.
Any other questions? I don't think there's any on this.
Yeah, I don't think so either. And I feel like I'm basically done with it there. I don't think we need another 30 minutes if nobody has questions. So yeah, that was microservices. They are it's kind of a weird thing to explain, because it's basically It's basically like client server kind of vibe, but in this era of distributed computing, microservices run a lot of the software that you interact with daily, like your social media and your cloud drive applications. Those are all just like a series of remote procedure calls stitched together. So it's definitely good to know about them, even though they aren't like super like stimulating. But I find it really interesting, and definitely make sure to keep an eye on the microservices repository, because I will continue to update that. Since it's in Python, it's pretty low maintenance compared to like C++ remote procedure call code. So yeah, that is all I have for this. Thank you everybody who came in person, and everybody on the Discord as well for listening. Oh, thank you. I had my hat too. Got to wear it.
That's a cool hat.
Thank you. It spins in the wind.
Everyone in the Discord, if you'd come in person, you'd also see that.
Yeah. So I'll stop streaming my screen here. I'll humor everybody who's left. They can see it with my camera. Yeah. All right. Okay, I'm done now. I'm gonna. What's that?
Is it once a week?
I wanted to do another one next week, but then I got so wrapped up in trying to find a room for here, I haven't planned anything yet. But I'll put an announcement out soon about like another event. Disconnect quietly. Disconnect and end.
Yeah, might as well send it.
Yeah. I think at this point we're good. Yeah, thank you so much. And what was your name? Angelo, nice to meet you. Justin.
For like next week, like topics.
We don't have any events for next week. Tomorrow there's like an introduction to web development.
Yeah.
But it sounds like with you knowing what API calls are, that might not be for you.
Yeah,
But-
next one we were thinking was like playing like a shorter event, probably like 15 to 20 minutes or so, going over like different like AI stuff, like OpenAI and or like the stable diffusion, like image model stuff. So I haven't been able to plan it because like I just told him.
So we don't have weekly events, but we just come up with events and then we put them out.
Yeah, basically.
So if you're a member of the Discord, if you're a member of the chat, then you'll get notified when we post those events.
I think I